Okay guys, so tonight what we're going to do is we're going to take a look at a truss that is it's ultimately going to be a 45-45-90 truss, but it's a pretty simple truss to do. Basically what you're looking at, it's 20 feet tall, it's 40 feet wide, the center support comes down in the middle, and it's directly in the middle. So it's essentially two 45-45-90 triangles side by side. So what we're going to do is we're going to try to figure out what the reaction forces are here, what the reaction force is here, what all of the members are feeling. So how much force is on AD, DB, DC, AB, and BC, and if they are in tension or compression. So that's the ultimate goal we have for today. So a couple things we need to do. First, I need to give you a size or a force that we're dealing with here. So we're going to put a force right at B, and what that force is going to look like, it's going to be straight up and down, and we're going to say it is 1,500 pounds. Great. So what we're going to do is we're going to see how that 1,500 pounds affects the entire truss, and ultimately trying to figure out again which one of these beams has to be the largest, which one can be the smallest, depending on magnitude and also tension compression. So before we do that, one of the first things I do is I figure out all of my lengths and I figure out all of my angles. I like to group things together. Lengths and angles, they go relatively together, so that's what we're going to do. That's what I usually start with. So what we're going to do is we're going to find angle right here. We're going to call that angle, we're going to call it DAB. DAB. Alright, so we need to find that angle, and I'm sure there's some of you out there that are yelling right now and telling me what it is already, because it's pretty obvious. But for those of you that it's not, no worries, I'm going to show you how to do it. So we need to find this angle, so we're going to use either sine, cosine, tangent, depending. So what we're going to use is we have 20 feet tall here, which is the opposite leg, and we have 20 feet long here, which is our adjacent leg. So if we take a look at SOHCAHTOA real quick, what we're going to do is we are going to use opposite and adjacent right here. So we're going to do the inverse tangent, so tangent -1, and we're going to do the opposite value, which is 20 feet, over the adjacent value, which is also 20. And we're going to get an angle of 45 degrees. Now, like I told you at the beginning of the video, it's a 45-45-90 triangle. So I'm going to let the cat out of the bag here, and I'm just going to say this is a 45, and this is a 45. This is a 90. This is a 45. And this is a 45-degree angle. But essentially you could do this process, this tangent -1, for any of them, and you would ultimately get 45 degrees no matter how you did it. So like I said, I like to start and do that stuff early, get it out of the way, and that way we don't have to worry about it. Alright, so next step we're going to do is we're going to get rid of those supports, and we're going to replace them with their reaction forces. So what we're going to do is we're going to get rid of those supports, replace them with reaction forces. So we have a pin over on the left, we have a roller over on the right. So turn them off, we're going to come back, and we're going to start this problem. So just do that real quick. Alright, so we have one here in the Y direction and one here in the X direction. Again, it was a pin. A pin gets replaced with two reaction forces. We don't know which way they're going. We're taking a guess. My guess is always a positive guess, just because that's how I do it. We're going to call this one RA in the Y direction. Call this one RA in the X direction. Now, over here, if we come back and we take a look at those again, you notice that surface is going horizontal. So our support is going to be vertical. It is perpendicular to that surface. So we're going to call this one RCY. Reaction, point, and direction. Right, okay? Awesome. So, now that we have that, we can start to work through all of our numbers and start to figure out. So the first thing we got to do is we got to do our reaction forces. So the best way we're going to start with that is we are going to start with moments. Sum of all moments need to equal 0. Well, in order to have a moment, we need to have a fulcrum. So, jump over. We're going to put a fulcrum where the pin was. The reason we put it at the pin is because we ultimately want to get rid of, we want to cancel out some of these forces. So I always put the pin where the most unknown forces are, most unknowns, which is obviously at point A this time. 9 times out of 10, it's going to be where the pin is. And then what we're going to do is we're going to come back and we are going to essentially, we're going to hold that fulcrum in place and we're going to push at all of our forces. So if I push at RAY, because I'm pushing directly on the fulcrum, this thing's not going to spin. If I push at RAX, this thing's not going to spin because, again, I'm pushing directly on a fulcrum. It's not going to spin. If I push at the 1,500 pounds, this thing is going to want to spin clockwise. So what we're going to make it is negative. And if we push at RCY, we're going to get counterclockwise, which in our case is a positive. So, jump back up here, and I'll keep that color, why not? We have a negative moment from B, so we're going to go negative moment B, and we have a positive moment at point C, positive moment from point C. We're going to break those up even farther. So to find a moment equals force times distance, which is perpendicular. So our force at point B is 1,500 pounds. So 1,500 times our distance, our perpendicular distance. How far is 1,500 from that fulcrum? 20 feet. MC, our force is RCY. And our distance is now 40. So 20 plus 20, the whole entire distance. Great. We're getting somewhere now. So, then negative 1,500 times 20 is negative 30,000. RCY 40. We're going to bring RCY, we're going to bring the 30,000, I think I added a 0 there, to both sides. So we're going to get a positive 30,000 equals RCY 40. And we're going to divide by 40. Divide by 40 there. And we're going to get RCY equals 750 pounds. Awesome. 750 pounds. So we're going to come over here and we're just going to put 750. Now, the next step we're going to do is we are going to do sum of all forces in the x direction need to equal 0, and sum of all forces in the y direction need to equal 0. Put a line right there. So all of our forces in the x, well, we only have one, RAX. Now, some of you asked me, are we ever going to have a value for RAX? And the answer is yes. If we have a horizontal force like the 1,500, but instead of going vertical, we have it horizontal, yes, then that number will actually be a number. It won't be 0. So keep paying attention to that kind of stuff. Okay? So, right now, what are our forces in the y direction? Well, we have a positive RAY over here, and we have a negative 1500, and we have a positive 750 that we just found right here. And RAY equals 750 pounds. I'm sure that some of you knew that already right off the bat. Why? Well, because this force is directly in the center of this thing. Well, when it's directly in the center, that means that this is going to be 750. This is going to be 750. These numbers are going to be half of what that is going to be because it's directly in the center. Great. So that is the, I don't want to say the hardest part done, but it's certainly a big component of us. It gets us started, it gets us rolling. So we are going to, I'm going to leave, or I'm going to get rid of all the stuff on the right hand side. Kind of a nice thing about doing it on the computer. Great. Because we are definitely going to need the room. Alright. So the next part that we're going to do is we are going to do point drawings. Free body diagrams of each point. And where do we start, though? That's always the question. Well, we're going to start at the point that we know the most information about. So we know that this is 0. We know this is 750. So we know quite a bit about that point. So that's what we're going to do. We're going to start with point A. Point A, right there, we have RAY going up with 750 pounds. We have RAX going to the right or to the left, it really doesn't matter. We have a member coming in from the right, or coming in, we're going to call it member AB, and we have a member right here, call this one AD. Now, let's put our dimension on there because that is important. Or not our dimension, our angle, sorry. And what we're going to do is we're going to take a look at this. Now, we don't know what these values are, AD and AB. We just don't know what they are. So we're going to make an assumption. The assumption is, if you don't know them, you're going to assume them in tension, and a tension arrow always, and I'm going to write this nice and big, always points away from the point. Always, always, always points away from the point. A tension arrow always points away from the point. Okay? Got to remember that kind of stuff because that is definitely a big component. Alright, so again, we don't know what it is, so we're just going to take a guess and we're going to say they're in tension. So we're going to put an arrow on the away side of that line. Alright, so now we're going to do sum of all forces in the x direction. And we're going to do sum of all forces in the y direction. So let's do sum of all the x's first. We have RAX, which is 0. We have AB, which is going right. And we also have, buried deep inside this thing, we have a horizontal component. We're going to call ADX. And we have a vertical component we're going to call ADY. They are components of AD. So ADX is pushing it right, ADX or ADY is pushing it vertical. So we have to include that. So what we're going to do is we're going to say plus ADX. So let's put some numbers to this. So 0, RAY is 0, so we're just going to drop it because it doesn't really matter anymore. And we get 0 equals AB plus ADX. We can't go any farther with that. We're stuck. Can't go any farther because we have two variables. So we're just going to have to deal with it. So we're going to leave that one alone for a little bit. We'll come back to it. Sum of all forces in the y direction. Well, we have a positive 750 pounds here, and we have a vertical ADY. That's our only two vertical forces, so we're going to get ADY equals negative 750 pounds. Now, that negative right here is important, very, because this is where people get kind of lost, so make sure you're really paying attention. What that negative does is it tells you that our assumption of ADY was incorrect. We assumed it to go up, so it's actually not up, it's down. So I'm going to make it nice and big. Now, when you do that, when you flip the component of a vector, if you have to flip everything, so that means that this is now actually going, or not now actually, it is going to the left, so it's going down and left, which means that this thing is actually going down and left. We're going to turn that into a little arrowhead to cover up that. So that means that AD is going down and left. Now, we assume that to be in tension. Well, we just got confirmation that it's actually the other way. So we assumed it tension, we flipped it around, so we are in compression now. So the AD is in compression. Now, how does that help us? Well, right now we have a triangle that looks like this. This is a 45-degree angle. We have ADY as 750. You notice I'm not using that negative here. That negative only helps me choose directions. That's it. It doesn't work into the numbers on this stuff. So, two things we need to find here. We need to find ADX and we need to find AD. Because we need AD for the whole drawing and we need ADX for this guy right here. So, what we can do, let's find ADX first. So ADX, so we have opposite, and ADX is adjacent, so our trig function that has opposite and adjacent is going to be tangent. So tangent of 45 degrees equals 750 over ADX. And when you flip it all around, you're going to get ADX equals 750 pounds over tangent 45. And you get an answer, ADX equals, look at my sheet here, ADX equals, 750 pounds. This number is the same as this, only in this problem because it's a 45 degree. For every 750 you go over, you go up 750. So, 750. So we can put that into this problem. Now, I kind of made a goof and I forgot. Sometimes I forget, and I'm usually pretty good about catching it. But I made one little forgetful mistake to remind you guys. We changed this arrow right here. We made this arrow go left when before we had it going positive. So this is actually going to be a negative now because it's going left. So it's going to end up being 0 equals AB minus 750. And we get AB equals a positive 750 pounds. So what that means for us is we're not changing the arrow at that point. So we are in tension. Great. Alright, one last thing. We got to finish with this AD. So we have opposite, we have adjacent, we need hypotenuse. Now, my rule of thumb is use the least deep number you can. So, the least deep number in this case is going to be the 750 over here. So that's opposite. We need hypotenuse. So we're going to use sine. Sine 45 equals 750, which is our opposite value, over AD. Flip it all around. AD equals 750 over the sine of 45. Great. So we get AD equals 1,060.66 pounds. Now, that means that this thing is 1,060.66 pounds. Now, once we're done with that point drawing, we're going to take all of those key numbers and we're going to move them up. So we're going to come up to the top here, and I'm going to keep with that pink because it stands out pretty well. We're going to come up here, and we are going to say AD equals 1060.66, and it is in compression, and we're going to say down here AB is 750 pounds, and it is in tension. Great. So we're working our way around. That's probably the biggest milestone that we have right there. All right, next step. And I'm going to clear all this, so if you haven't gotten it all down or you need to take a look at it, obviously you can pause. And the beautiful thing about these videos, right? Okay. Now, we need to choose another point. The next point that we're going to do is a point that we know, again, the most information about that we can work from. Now, we obviously already did point A, so we can't do point A. We can do point C. We'll probably run into something where we don't know something. So what I usually do is when I start at a point, I just slowly work my way around. So we can go to either point D or point B. To be honest with you, I would stay the heck away from point D because it's got two angled lines, two angled members, which means for every angled member, you have a force vector, essentially. So you have two components. That means you have four components. You have this force. You get a whole bunch of stuff that you just don't want to have to deal with. This one right here, 90-degree angles, that's where I'm going. So what we're going to do is we're going to do a drawing of point B, and we're going to say BD right there. We're going to assume it to be in tension. We're going to assume BC to also be in tension because we don't know. 1,500 pounds going down. And then this is sometimes the trip up. That arrow is going left, so AB equals 750 right there. But the trip up is, in this drawing it is going left, but in the other drawing it was going right. The reason is because tension. It's in tension. If you remember that big, huge drawing I put up here, tension arrows always go away from the point. Well, this is in tension, so that arrow goes away from the point. All right. Sum of all forces in the x direction. You'll see how easy this one is. So we have negative 750, and we have a positive BC. BC equals 750. Awesome. 750, and we get a positive value, which means our assumption was correct. Tension. Done. Sum of all forces in the y direction need to equal 0. So we have a negative 1,500, and we have a positive BD, we think. And lo and behold, we have 1,500 equals BD. Again, positive number. So, BD is 1,500, and it is also in tension. And hopefully you're starting to see how this works, or you're getting caught onto it. 1,500, that's in tension, and that is BD. This guy is BC 750, and it is also in tension. Okay, and last point. Again, I'm going to erase this. Let's go back. All right, last point. Now, do we choose point D or do we choose point C? Again, either one will work. But here's the problem. That's a lot of work. This is a lot less work. So if you're like me, I'll take the road that's a little bit easier if it still gets me the right numbers. So we have RCY coming up with 750 pounds here. We have BC, which is in tension, so we're going to put the little arrow going away. BC, 750. And then we have CD here, which we're going to assume in tension. And we're going to throw on that arrow. I'm in that angle. And I'm sure some of you are chomping at the bit. You already know what the answer is, because you know what kind of triangle we're dealing with, but we'll work through the whole thing, make sure we're all on the same page. So, sum of all forces in the x direction. Again, same process. We have negative 750 pounds. And we have, change colors here real quick. We have component CDX, and we have component CDY. So that CDX we think is going left, or we're assuming. So we're gonna make it CDX over here, and you're gonna notice real quick, CDX equals negative 750 pounds. And again, what that negative does is it causes one heck of a problem for me, because I have to go in and change those arrows. So this thing is not going left, it's actually going right, which means this thing is not going up, it's actually going down, which means that this is actually going down and right. And I apologize, that's the one thing I hate about having to change, is it gets a little messy. But this guy's going, just so you can see that, it's going this way. Going down and right now. Now, we now have a triangle that looks like this. 45, 750, and we need CD. So, we can do the cosine of 45 equals 750 over CD. And we're going to do a little flip. CD equals 750 divided by the cosine of 45. And you get CD equals 1060.66. 1060.66. And we had to do the flip, so we're in compression. So we're going to come back up here, switch my color to the, kind of the same color. Compression. CD equals 1060.66. Whew. It's a long problem. But what you can see very quickly is a 1,500 pound force is creating 750 pounds of tension over here, 750 pounds of tension on BC, 1,500 pounds of tension on BD, about a little over 1,000 pounds of compression on AD, and a little over 1,000 on CD. Now, what does that mean for us? If we were actually going to build this, now there's a lot of other variables that go into this, but these compression forces are way worse than those tension forces on a slender member. Right? You take a ruler and you try to pull it apart, it's going to withstand that force pretty well. You take a ruler and you push in towards the center, that ruler is probably going to bend relatively easy. That's compression. It's not really going to like it. So we're going to have to work around it. So these two forces here, even though they're only only 1,000, but they're 1,000 pounds. These are probably in the upward area of just as worse as that, if not worse. So definitely something to think about when you're putting these things together. But that's how you get all the numbers. Couple things that people make mistakes on is when they flip arrows. If you think back to when we were doing over here, when you flip, you get a negative over here, you also need to change everything. So if you've already written a formula, you also need to go back in and put a negative in there, or positive, depending on what you're doing. But when you make changes, when you get negatives, it affects a lot. So you really got to pay attention to that kind of stuff. Couple other things you can take note of, because it's a 45, 45, 90 triangle, and it's has a line of symmetry directly down the center. You notice the numbers are very consistent. 750 over here, 750 here, 1060 here, 1060 here, right? Couple things you can't do. You cannot do Pythagorean theorem in this triangle to find hypotenuse. So you can't get 750 and 1500 to find 1060. It doesn't work like that. Pythagorean theorem only works on single triangles. This is not a single triangle. It's a double triangle. So these forces are all acting and influencing each other. So you really got to pay attention to that kind of stuff. You really got to pay attention. All right, guys. Well, it's been a long video here for this one, but as you can see, definitely doable. And make sure you're paying attention to the signs.